All right, so we're going to move on to Robin Resnick's Chapter 2, exercise problem number 3. Vector A has a magnitude of 5.2 units and is directed east. You see here how they say units instead of meters. And is directed east. Vector B has a magnitude of 4.3 units and is directed 35 degrees west of north. By constructing a vector diagram, find the magnitude and direction of A plus B and A minus B. Well, it's kind of the same thing that we just did, except for here we have east and west. I'm sorry, east and what is that? West of north.
So what was that? Vector A. So first of all, we have vector A, magnitude 5.2 units, and that's going to be east. All right, then we have vector B, and that's magnitude 4.3 units. And that is, what did they say? West of north? Did they say west of north? West of north. Did they say west of north? 35 degrees west of north. That is 35 degrees west of north. Alright, let's try to draw this out so we get a visual of what this looks like. Alright, so I'm going to create a plane, okay? I want to say, yo, that's ugly. I'm going to create a plane. I want to say my top is going to be Y. Alright? I can't draw nothing, huh? Alright, my top's going to be Y, and my bottom's going to be negative Y. My right's going to be X, and my left's going to be negative X. Okay? So, just regular north, south, east, west. Alright, so 35 degrees. Well, first of all, we're going to do vector A. And vector A, let me go ahead and create this plane, and I'm going to make it, what color? Orange. Alright, I'm going to make this plane. Make this orange plane. Alright, so in the middle is going to be my point 0, 0. Alright, that's going to be a point in the middle. Alright, nobody really does that, so I'll erase it, but that was just kind of to show you guys. Alright, so we have vector A, which is 5.2 east. Of course, you want these lines to match up, but, you know, I'm not the most perfect drawer, illustrator, so that's going to be 5.2. Okay, and this is, we can call this vector A. Then we have vector B, which is 4.3, 35 degrees west of north. Okay, so since this is north, and I'm saying that this is west, alright? So west of north would be 35 degrees in that direction. Alright? And this magnitude of this guy is going to be 4.3. Okay, and we can label this as a vector B. Alright, well now that we have basically the layout of what it is going to look like, alright? And then we can find some more information out. Alright, that's what I like to do first. Find out all that you can find out. Okay? That's how much the vectors are separated by. So they could have just said, you know, instead of saying all this west of north and all this other stuff, they could have just said that the two vectors are separated by an angle of 125. Alright? Or they even could have done 125 subtracted by 365, which would be 240. But, you know, let's not get into that. Let's not get deeper than we need to get, right? The purpose of all this is just a review. Okay? Alright. Okay, so we have a angle of 125 separating the two vectors. They want us to find, what do they want us to do? They want us to do A plus B. And then we're just going to say, I want to keep a simple resultant vector, and then A minus B. Resultant vector 2. So the way that I like to do this, okay, is I like to describe the vector in its full form, since we already know it's in a Super Saiyan full form, since we already know we're doing two-dimensional. Right? And the reason we're doing two-dimensional is because B has a y dimension. There's an angle, which introduces another dimension. If there was no other dimension, if there's only one dimension, then we would not have an angle. If only one dimension, well, let me not say that. I don't want to say that. But when we have one dimension, there is no reason for us to have an angle. No reason for an angle under one dimension. That's what I'll say. No reason to have an angle under ill. Okay, because in this case scenario, the particle or whatever, it's either moving left or right. Right? There's no up and down. The fact that there is up and down introduces an angle. I hope that's understood. Alright, but in this particular problem is not one dimensional. So it's multi-dimensional, it's 2 dimensions. So we introduce this angle. We account for it. And because we do that, we have to break the B vector into 2 parts. But right now, let's just worry about the A, vector A. So vector A is 5.2. And I am just going to do, I'm going to go and do degrees anyways, at 0 degrees. Okay, we could just say east, but saying 0 degrees, same thing. Alright, okay. Now, vector B. How do we find what vector B is? Because it's not, we can't say 4.3 at 180 degrees. We can't say that, right? We can't say 4.3 at west, right? Can't do that. What do they give us this angle for? Right? Okay, so because vector b shares dimensions, it shares dimensions with the x-axis and the y-axis. Okay, because vector b shares dimensions, we have to break it up into two. All right, that's what I like to do. I like to break it up into two. Okay, so I have a bx and I have a by. All right, my bx is described by the magnitude of b. Goodness, I forgot. Cosine the angle that it shares, the angle of shared dimension, basically, and that's it. B sine. I don't really feel like deriving this or telling you why, but if you want to understand, I'm sure you'll get it. You'll get the hang of it. Okay, so cosine is always going to be in the horizontal direction, and sine is always going to be in the vertical direction. Not always, but most likely. Okay, and so what does that equal? That equals 4.3 because that's the magnitude of b.
A negative should be applied in front of the magnitude because the vector is moving in the negative x direction.
Times the cosine of the angle that we have, which is, oh, instead of saying 35, okay, my mistake. Am I tripping? Common mistake. Common mistake. Okay. Alright, this angle here, theta, okay, is the angle of the right triangle. That's why. This is cosine of sine. Okay, boom, cosine. And that's going to be sine. Alright, and this makes a right triangle. We can only break this up into parts when we have a right triangle. Okay, we cannot do the cosine sine thing with an obtuse triangle. It's not going to work. Okay, that's the second part about it. We can only do this with a right triangle. What would be the purpose in doing this with an obtuse triangle? Right, because when you break up this vector here, you would yet again have additional sine and cosines. Alright, so the angle theta here is actually, this angle theta is actually this guy. Alright, and the reason that is I'm making that angle this guy adjacent to the x-axis, because if I draw this line straight down, that's a right triangle. Alright, and so by finding that right triangle, I can then I can use that theta, okay, to then find the x division, the x component of the b, vector b. Goodness gracious, I have to say all these words right. Good. Okay, so that is going to be 4 point, ooh, ugly 4. That's going to be 4.3? 4.3 cosine. How do I find theta? Theta is 90 subtracted by 35, okay, which is 55. We all know that. 55. Alright. B sine theta, so that's 4.3 because that's the magnitude of b. Sine, okay, and then that's going to be 55 again. This comes out to 2.46 in the x direction, and then 3.52 in the y direction. Alright, you probably shouldn't put parenthesis x because your professor's going to think that you're trying to say multiply by x, but I'm just putting that there to remind myself. Okay, we're almost there. Alright? We're almost there.